Hello, welcome to today's webinar about how to think in T-Splines. I am Matt Cedarberg, the CEO of T-Splines Inc., and I am joined today by Kyle Houchins, who will be presenting most of the webinar. Kyle is the owner of The Outside Digital Art and Design, where his own design consultancy where he uses T-Splines for his own work. The motivation behind today's webinar came from a T-Splines training class that I gave in London, England earlier this month. During these training sessions, we usually methodically work through our carefully written T-Splines training manual to expose the participants to as many commands as possible. However, in this London class, I decided to take a somewhat different approach. I slowed things way down, and with each tutorial model we made, we spent a lot of time discussing why we did things a certain way. The fact of the matter is that T-Splines gives you tools and a flexibility that doesn't exist with NURBS. And so with T-Splines, it's very easy to iterate on your model and make changes. However, to fully realize these benefits, you need to have built your model in a good way. Like NURBS, when you model with T-Splines, if you start off on the wrong foot, it can be difficult to get the results you want towards the end of your model. So today, Kyle is going to walk us through modeling a few simple objects, and he'll focus on more of the thought process that he's going through instead of the actual click-by-click steps. My hope is that you'll chime in with plenty of questions while he's modeling. You can just type your questions in the GoToWebinar box, and we'll type back answers. If it seems relevant, we'll interrupt Kyle to ask him to demonstrate how to do what you're curious about. I hope that this can somewhat simulate a live class where you get the benefit of asking questions to really understand what's going on, so that at the end of the webinar you'll be able to approach your T-Splines projects in a way that can maximize the benefits you can get from T-Splines. So with that, before we turn the time over to Kyle, I just had one other business item, and that's to give you an update on the T-Splines design contest. This is what we have going on right now with over $15,000 in prizes. It's over 100 prizes, a number of categories, and that deadline's coming up in about 2 weeks. So you can just register at tsplines.com/contest to get a lot of free trial software to use during the contest, and we hope that you will submit an entry so we can get rid of all those prizes. And just one final comment. This webinar is again, as we mentioned, it's mainly targeted on people that have been exposed a little bit to T-Splines. If you're a very beginner, I'd recommend going to our website tsplines.com and checking out a recorded webinar where you can learn more about the very beginning information. But hopefully this will be a good webinar. So with that, let me turn the time over to Kyle.
Hi everybody. Thanks for coming. This webinar is going to be, I don't know, considerably different than kind of the typical, workflow demo video that Matt and I typically do. And what I wanted to do is discuss a couple of different strategies for kind of how you get there in T-Splines. And I know when I was originally starting to learn T-Splines, I had a kind of a mental disconnect as far as how exactly do I start to build things. Because when I was originally looking at T-Splines, I was trying to shove it into my typical NURBS workflow paradigm, which for me is very similar to the paper models I used to build as a kid. I'd cut out a sheet of paper, I'd cut out another sheet of paper, so essentially I had two trimmed surfaces, I'd tape the edges together and continue until I captured some volume. And the thought behind that, taking a surface, trimming it into a shape, and then taping it to another surface that you've trimmed into a shape, is a very kind of typical NURBS paradigm. A lot of times people refer to it as overbuilding, where you build surfaces that intersect and then trim them back. And it made sense to me because, like I said, it was something that I had been doing for a long time. When I got into T-Splines, I didn't have very much exposure to polygonal modeling or box modeling or sub-D modeling or anything like that. And so I was trying to fit it into the paradigm that I was used to, and I had a considerable amount of difficulty. In fact, when I had originally tried T-Splines at version 1, I picked at it for a week or two and then basically, threw my hands up and abandoned it until somewhere right before version 2 came out, when Matt and I met for the first time. And so kind of through this journey of getting my head around how you actually do stuff and learning more about polygonal modeling and sub-D modeling and stuff like that, I've kind of put together a couple of different scenarios of how you capture different shapes. And I wanted to try and share my thought process on that. And the idea of this webinar is more to expose everyone to kind of my idea behind how I typically build stuff, but also to foster some discussion, to give you some ideas about things that you maybe had not thought about, ways of building models and in T-Splines and things like that. So that's kind of what we're thinking here, and let's just go ahead and jump into the first shape here. Anyone who's taken the T-Splines training will recognize this as one of the first exercises that we do in the class, and it's a simple handheld, TV remote, telephone, some sort of object that would be a consumer product shape. And if I shade this without the isoparams on, you'll see that it's a really nice, flowing, fairly simplistic shape. But if you analyze this from a NURBS modeling perspective, this actually would be a fairly complicated thing to model with this level of continuity. And this is kind of the first one or two steps that I always try and push people towards when they're learning T-Splines. And this I refer to as box modeling. And essentially the idea behind this is that you take a primitive shape, in this case a box, and we basically just lay out a box that matches the topology that we're looking for, and push or pull the points of the model to get what we want. And in this case, I'm not going to go through and demo the entire thing, but essentially what we're doing is, I've got symmetry turned on, is we're just going to push and pull points on this model until we get the shapes that we're looking for. And it's a fairly simplistic way of looking at it, and it's a very simple way, a very accessible way to start getting into T-Splines modeling. And I would encourage anyone who hasn't done this already to just grab some primitives and start pushing points around until you get, you start, realizing some shapes here. So that's kind of box modeling, and there's a couple of tutorials on the web that represent this. And the dolphin, off the top of my head, I can't. That's the one that I'm coming up with here. But
yeah, Kyle, we actually added this exact tutorial onto our new user page. So.
Oh, there you go. All right. So you can see by pushing and pulling on this thing, and I'm going to kill symmetry because this is driving me nuts already. By pushing and pulling on this thing, we can very quickly get some shapes that would be difficult to get in NURBS. But are really accessible in T-Splines just by pushing and pulling stuff around. And I'm not going to beat this to death, but otherwise my designer geek will start showing, and we'll spend the next 2 hours designing a TV remote. But you get the idea. This one's asymmetrical for right-handers. The next style of modeling would be what I like to refer to as kind of a primitive modeling set, and it's very similar to the box modeling mindset. And the shape like this was an example that we were working on for a client that wanted us to demo something like this. And basically what we did was we started with, again, a simple primitive and cut it in half subdivided it, and then basically matched up the topology that we needed in order to get the number of tines here. Because the faces, basically, I didn't have enough faces here to line up with as many fingers as I needed on this fork. So I went back and I subdivided each one of these exterior faces, and then made sure that I had enough topology here so that I could extrude these out. When I made the handle was essentially a piped object, which makes sense because it's kind of tubular and long, and then just bridged between the spoon portion that had these pieces extruded out of it and the piped portion back here, which basically allowed me to create a fairly complicated part with really only 2 or 3 commands. It was a primitive, it was a thicken, it was extrude for the fingers, it was a pipe, and then a bridge between the two. And you know, this model took about, I don't know, I would say 15-20 minutes in order to make. And the good thing about this is once you've got this shape made, especially if you're a product design environment, you can then variate on it, you know, 1,000,000 times to Sunday and you know, come up with half a dozen different proposals for your client that they can review. So look at the shape of what you're building and think about what makes sense as a starting point. In this case, I had a round end that was spooned on one end, and I had a long handle. So this says to me half of a sphere. This says to me a pipe. And the other thing that I ended up using is actually, I'm misrepresenting my workflow just a hair here. I didn't use half of this sphere. I used half of this sphere, which is the quad ball sphere. If you'll notice, the topology here is not laid out radially. I originally started messing around with this with the radial symmetry, and I was not getting the kind of result down here that I wanted. So I ended up using the quad ball sphere in order to create this. And if you notice, basically the layout that we have here is the same type of layout that I'm showing here. All I did to get the additional topology that I needed was to grab this, subdivide the entire thing exactly, and then you'll notice this starts becoming very recognizable. Thicken it. I've now got enough information here where I can lay out my fingers, and then add the pipe, bridge between the two. Does that make sense? Everybody following me still? Please feel free to shout out questions or heckle me or whatever you want to do as far as this. We're trying to do this webinar a little bit differently so that it's more of a prompting you to think about how you build stuff as opposed to actually demoing a workflow as far to build a specific object. So primitive and pipe, the original was just a simple primitive pushing it around. The third thing that I show a lot, and if you've seen this webinar is actually recorded so you can go back and see exactly how we built this object. But this object here, at first thought, you may say, okay, well, this would be a simple thing to start with a primitive and start pushing and pulling. And it would, for the most part. If we look at this in just a simple top view, it's a fairly flat, fairly regular shape. And you may think that that would lend itself well to a simple, primitive layout. You could take a box and lay it out, subdivide it to get the number of faces that you wanted and things like that. But in this case, I wanted to try and keep the topology as simple as possible. And basically what I had was there's a bone line that runs through the center of this object that is the high point. And then there's finger grips in here, and I'll spin this around a little bit so the highlights show a little better. But there's finger grips in here that had a little bit of subtle surface undulation. And in order to be able to control that exactly how I had it pictured in my mind, I need to get topology that's very similar to this. I needed squares to be able to push down in here where the fingers are. I needed squares in order to be able to push up where the ridges are. And then I needed a row of squares here and a row of squares here in order to be able to allow the object to bend like this, because basically it has a little bit of a shape like that. And so this was built with what I like to refer to as the append face workflow, and I beat on this a lot. I've been accused of having that be the only workflow I know, and you know, okay, busted. This is what I use for 99% of what I build, and basically it consists of starting with a single face and then picking an edge and alt dragging out to get the shapes I need. And then basically what I do is move this into shape. Grab this edge, alt drag up, and you can start to see how you would begin to lay out the paper doll that eventually ends up turning into this model. And we would add some more, we would subdivide this a little bit in order to be able to get the undulations in here, get to the certain point where you've got the topology laid out the way you want it, and then it would just be a simple matter of thickening this in order to get the shape that you wanted. Start pushing and pulling on faces in order to get the undulations and things like that. Append face has been demoed. I've demoed it, you know, a bunch. The iron, the helicopter, this knife, countless other things. It's super powerful. It's kind of one step up above primitive modeling, because what you're doing is specifically laying out faces to go exactly where you want. So if you've got an object that's not super conducive to being square, super conducive to being spherical, you know, is not a variation on a torus, is not a variation on a cone, but you need a little bit different shape in order to be able to add stuff. This append face workflow forces you to think about every patch that you're laying out, think about where it's going, and it also really simplifies the connection between the surfaces as far as not building one surface that's got 15 patches and now you have to attach it to another surface that's got 9 patches, and how do you make that complicated transition, and you know, all that kind of stuff. So I like it because it's a really organized way of thinking, and a way that I've explained it in the past is it's a lot like kind of a high concept art school project where your teacher says they want you to build, you know, a statue of Michelangelo's David using nothing but square Post-it notes. And how would you do that? So you'd take each one of those square Post-it notes, and obviously you'd need a billion of them, but you'd take each one of those square Post-it notes and attach them edge to edge to make a perfectly laid out quad face model that captured everything that you wanted to do. And so if you think about it in its simplest form, if you think about T-Splines models as how would you build something if all you had to build it was sticky notes, I think that'll get you a long way as far as getting started with how to think about how to build something in T-Splines.
Kyle.
Yes.
We're starting to get some questions, which is exactly what I was hoping for. All right. So here's a question from Mark. Is there a way to thicken in both directions? Like in nerves, you can extrude from both sides. And let me just tell you kind of my thoughts about this. Maybe you can demo it. So when you thicken it, just kind of creates one thickness. But instead, if you want to run the extrude command, this also gives you the chance to make it symmetrical. So if you grab all these faces and extrude them, then you can see, Kyle will go ahead and do that. If you just extrude them and pull them up. What this gives you is, if you look around to the bottom, it just gives you half of your model. It gives you an open half. So then if you apply the symmetry command and select the T-spline. You'll want to do axial symmetry, and then you'll just click 2 points to add symmetry. Now, in a way, you've kind of thickened it to both sides, and you have the added benefit of having symmetry. So now if you push on one side, it will update on the other side.
So the short answer to your question is no, you can't thicken in both directions. The long answer is you can accomplish that by using the extrude and symmetry commands.
And then, Kyle, could you also just show how to turn off symmetry in case they don't want symmetry
Absolutely.
on?
If you right-click on symmetry up here, if you hover over it, you'll notice left button is symmetry on, right button is symmetry off. Just click on it, and now it's gone. This workflow, and I don't mean to beat on this too terribly long here because I'm sure a lot of you guys have already heard this before from me, but this workflow was the thing that allowed me to turn the corner between being a grouchy old NURBS modeler that couldn't figure out how to work this newfangled tool, to being somebody who, this was my aha moment. This is where I was like, oh, I get it. And once I started looking at all these little post-it notes and said, oh, okay, I get this, and if I had an object that I was looking at in my hand, I started picturing how all the little squares would line up on it. And basically, once you get that concept, once you understand how all these little squares connect, now obviously you're not limited to squares, you can do n-gons, you can do triangles, but for the purpose of argument at this point, if you think in squares, you're going to be well on your way to building kind of nice clean models. So so this append face workflow I really like because it forces you to think in squares, it forces you to count while you're doing it. It forces you to, make the same number of edges here and there when you're trying to build, your primary surfaces to do transitions and stuff like that. And it's a really simplistic yet really, really powerful way to stay organized when you're trying to get your head wrapped around this. So,
Kyle, here's another question. If you want to maybe go back to the spaghetti scoop model before you move,
sure.
Before you go forward. So the question is, how can you move multiple objects in a radial fashion without scaling those objects? So like those end tines, if you wanted to move each of those radially.
To have them come straight out?
Yep.
What I would probably do in that case is I would... That's a good question.
What happens if you select them and then do move UVN? I wonder what that would do.
Yeah, let's see.
So do the translate manipulator with UVN.
So let's just grab the top edges there. If we change the drag mode to UVN, and let's just scale them, and I'm going to set the transformer.
You can't really scale with UVN, so you want to do the translate, Kyle.
Yeah.
Yeah, you want translate manipulator.
So if we move UVN, I don't know if that's quite.
Yeah, not really.
In this particular case, what I would probably do is, that's a good question. Cage edit it maybe? The other thing is with symmetry on, you could I don't know. Here's a good.
Yeah, with symmetry, you only have to do half of them. You could just do it on the one side.
Yeah, I'd maybe start with a reference object, like a curve, and then with symmetry on, move these to match. I don't know. That's a little wonky, but I would maybe work on, I would probably look at doing something like that. That's definitely not as satisfying as having a radial move tool, but that's probably how I would go about accomplishing that on this model.
Okay, yeah, that seems about best for me too. So here's another question.
Petitioning now for a radial move tool.
Here's another question, and I hope we still have the context for this. Is the primary problem the transition from even to odd number surfaces? Do you remember the context for that, Kyle, a couple minutes back?
Well, I think what he might be referring to as if I have one surface here. Let's just leave this, let's do this at like 10. So that I've got 7 edges here. And if I had another surface, if I copied this, and this one only had 5, how would I make the transition between these two? And that's when you start running into problems where you have to try and bridge stuff individually and weld, because 5 and 7 won't bridge together, but 2 or 3 and 3 will bridge, 1 and 2 will bridge, 1 and 2 will bridge. So what you'd have to do is you'd have to bridge these edges first, then these edges, or possibly even these edges, and then what you're going to do is you're going to have a stacked vert right here and right here. And so what you need to do is weld those, because if you bridged between these and then bridge between these and bridge between these,
why don't you just show that really quick, Kyle?
You're going to get a weird crease going on. Sure. So if we bridge, selection mode, edges, we bridge from here to here, that'll work. And then if we bridge here to here, that'll work. And if we bridge here to here, that'll work. And it looks like actually that it handled those verts. Through the power of the superior technology Matt has allowed us to have, that actually has worked well. What you want to be careful about when you run into scenarios like that is that you don't end up with a stacked vert. And if you find yourself if you find yourself in a situation where, let me just unweld one of these. Actually, I'll just unweld this edge. If you find yourself in a situation where you've got a weird crease running through the model, I don't think it'll let me unweld an internal edge like that. But if you find yourself where you've got a weird crease running through the model, like if I take this face out of here, if you get a situation like this where there's a face in there but you get a weird crease, that means that you've got a stacked vert at one of these corners, and all you need to do is just weld those and that'll go away. So in this case you can use the fill hole command and that'll weld up.
Awesome.
So that's when you run into a situation where, if you've got, 13 edges on this and 24 edges on that, you're going to have to go and you can't just do it all in one big long bridge. You have to do, line up 5 edges at a time, and then the ones that are left over, then you may have to adjust the topology so that you get, multiples that will work together. So Matt, the rule is it's got to be divisible, right? The edges have to be divisible.
One multiple. Yeah, one can be the multiple of the other. Okay, yeah. Sterling's told us about 5 times that he understands us now, so let's move on.
That dead horse is dead. All right, let's move on. The append face, we beat that one into the ground. The next one is pipe, and pipe is something that was added in a recent the most recent release. And pipe, I'm finding, is making its way more and more into my collective modeling conscious as far as how to lay stuff out. And in this case, this bike was a good example of something that was essentially laid out with pipes and then went back to box modeling after we laid this out and got all the transition with pipes, went back to box modeling and just pushed and pulled surfaces around in order to get a really interesting bike frame. The addition of the match command allows us to take things like, if I had to match this specifically to a headset curve, I can come in and run the match command. Double check to make sure that my alignment, I'm going to change this a little bit.
And by the way, this is one of the big differences between T-Splines and like subdivision surfaces, is this ability to match the end of a T-spline to a curve is unique.
This is so insanely great to be able to do this, so that I can essentially take a T-Splines model, I can match it to a NURBS curve, and then I know that this is matching up with my engineering requirements or whatever my hard points were for the model. So I know when I drop, an 1.125" headset in here, it's going to match the 1.125" setup. I can also match this to a NURBS surface. So if I had my cone and if I had my let me just blow this up. So this is a NURBS surface. If you look up here, it's coming up as a NURBS surface. I can also run the match command to a NURBS surface. So if I had engineering requirements, I could import them, use them as a reference. Modify my start point again just to drive that correctly. In this case, I'm just matching G0 because that's all I need, but it will do G1, G2. So I know that this is still a NURBS surface, this is still a T-spline surface. These two can exist in the same model space and work well together. And it allows me to be able to incorporate engineering requirements. If you were to use this and bring it into SolidWorks, you would know that all of your mechanical engineering parts that you built in SolidWorks are going to line up. And once you get it into the SolidWorks environment, you can fill these two together, all that kind of stuff, and still enjoy all the benefits of using T-Splines. So let's look at what this model originally was. And basically, all it started out was this. And it was a bunch of curves laid out. Looks like I'm missing one or two, but it was a bunch of curves laid out that that were piped and blended together, and then pushed and pulled in order to get the bike model. Any questions on that?
None on my end.
Okay. Juan did a phenomenal bike frame pipe demo that's recorded on the web. I would highly, highly recommend looking into that. Pipe works great not only for bicycle stuff, but the jewelry guys are loving this because you can pipe a bunch of stuff together and then run one of the Rhino UDTs on them. You can bend them, twist them, pull them, stretch them, flow them along a surface, all that kind of stuff. And that's really awesome for creating some pretty crazy jewelry stuff. All right, the next thing that I wanted to look at was starting with an individual curve, and I tried to use examples for this with stuff that's already been demoed on the web so that you can go back if you want to look at exactly how each one of these parts was built. You can go back to the web and watch this. This golf club was recorded, the bicycle frame was recorded, all that stuff. So you can go back and review that stuff in depth if you want to. But basically this golf club started off with a single curve. And for the purposes of this demo, I was assuming that this curve was given to me by an engineer, and this was the envelope that I needed to work on. And so basically what happened here is I started with a single curve and just alt dragged out the body, and then if I grab my curve and get rid of it, because I don't need it anymore, I can grab my edge and I can alt scale to start getting my face, and then it's a simple matter of bridging and welding to get the face in here. If I bridge between here and here, here and here, I've got two faces in between, so I want to use two segments. This is going to look really ugly once I send it because it's not welded. All I need to do at this point to close up this face, pre-pick these and hit the Z key. Now, this is something that used to kill me when I was getting started, is I would do something like this and, quote, ruin my model. I would throw my hands up in frustration and quit because I thought I had broken something and I couldn't figure out what was going on. All you need to do is just keep going and the world returns to normal. And so what I was doing was I was quitting way too early, and I had all sorts of unresolved inside edges and things like that, and I just didn't know enough about how to think in T-Splines to understand what I was doing. And you can see how very quickly you can put together something like this. And I'm just going to fugly this in the back by filling this hole. And you can see how you can very quickly create a shape, and then to get the hosel out, just extruded these two faces here. And we're going to make uniform just to straighten everything back out. And then you can see very quickly how you could start, again, now going back to your original box modeling and start pushing and pulling faces around to get what you wanted. So starting with a single curve is something that's really super powerful because you can create really complicated shapes starting from a NURBS model, and all you need to do is now go back and straighten out your lines, but this is a legitimate T-Splines object at this point.
So Kyle, here's a question from Kevin. As far as starting from curves, if Kevin has a picture of a freeform stone, just like as a JPEG, and he brings that into Rhino, do you know of any nifty ways to get kind of the edge of that stone besides just kind of tracing on the JPEG? There's not really any discover curve options in Rhino, is there?
Not in Rhino. There used to be an Adobe product called Streamline that a million years ago, when I was doing label art for logos, you'd scan something in and then streamline it in order to be able to identify edge curves. But to be honest, the curves that Streamline generates are such garbage that once you brought them from Adobe, from Streamline into Rhino as EPS files, you'd have to rebuild that curve anyways because it's just, it's got a million stacked verts and it'd have a million points on it and stuff like that. And so, honestly, I find using picture frame and tracing carefully is really the best way to go because it allows you to be able to control the topology and lay out a curve that has a reasonable amount of points as opposed to trying to, deal with a curve that's got a billion points. Because something like this, if I look at how many points this curve has, I laid this out like that. The problem is T-Splines inherits its topology from your curve. So if I rebuild this and say I rebuild it with 90 points, if I extrude this, I'm going to get 90 edges. You don't want that. You want nice, simple patch layout structure. You want to keep your T-Splines model as simple as possible. That's the whole idea.
Yeah, and this is something that Sky Greenwald talks about. He did an advanced T-Splines modeling webinar with us, and you can find that recording on our website. But when he was modeling NACA airfoils, even though his curves were, I mean, he wanted those to be really accurate, but they were really dense. And if you just rebuild those first, then it gives you a surface that gives you all the tolerance you need, and it's a lot easier to work with.
Yep. And that's exactly the point here. Is if I look at this and it's got a million points on it, I'm going to get a T-Splines object with 1,000,000 points. I can rebuild this curve, and say I can rebuild this to like 15 points. Well, I can check the deviation on this. Well, 0.45 is way too much, so I'm gonna crank this up to say 30 points and preview it. 0.12 is still too high. So you can work within your comfort level as far as of what your tolerance is, and go from there. So the other thing that I'll do a lot of times is if I can't rebuild it within tolerance, what I'll do is I'll drop this to something that I want and then go back to my original picture or curve or whatever it was, and I'll adjust the low density curve in order to match. Because what you want is you want this curve to be as simple as possible, so that your T-Splines object inherits however many edit points are on this curve. You want it to be something reasonable, so that you're not dealing with what you don't want. What you don't want to do is build something that when you originally extrude it looks like that, because now you've got 1,000,000 faces in here that you have to deal with. The more faces you have, the more chances you have of introducing inflections that you may or may not want. So try and keep it as simple. When you do this curve workflow, rebuild your curves to their very, very simplest state. Whatever the very minimum you can use without your shape falling apart, that's what you want to use as far as being able to build stuff like this. Okay? Any questions on that? All right.
I think we're great.
The last thing that I wanted to look at was something really complicated, like a bicycle helmet shell. And this model would be something that would give me explosive gastrointestinal distress if someone had asked me a couple years ago to build this in NURBS. This would have been a multi-week project. It would have been something that would have been a nightmare to try and variate or work with, because every single one of these little bi-rails would have had to been blended and filleted, and it just, there is no way I would have gotten this level of continuity on something like this. And this was something I put together in a couple of hours yesterday when I was prepping for this demo, and the ease in which this went together kind of reminded me why I like T-Splines so much in the first place. And if we step back a little bit and think about how in the world would you even begin starting, and I built this with zero art, by the way. I just made this up as I was going on. There wasn't a sketch. There wasn't anything. So if it's wildly unhead shaped, don't sue me, because it's just something I made up on the fly. Which again demonstrates how insanely powerful this piece of software is, because could you imagine trying to build something like this on the fly in T-Splines or in NURBS? It'd make you nuts, because it would make you nuts. So let's look at how this was built. And essentially what I did was I laid out some very basic curves. And what I did was I very simply extruded some strips that made up the basic forms of this helmet. And I didn't really even go all that nuts with making sure that they were lined up on the ends or anything like that. And then what I started doing was, but one thing you will notice is if I pick an edge here, there's 17 edges here, 17 edges here, 17 edges here, and that's a result of the original curves. Once I had the original curves built, I selected them all, rebuilt them all to the same point count. And the nice thing about that is I know that I'm going to have topology that's flowing through this thing because I had a general idea that I wanted the helmet to have, you know, kind of linear vents and stuff like that in it. So now it's simply a matter of going through. I've established, let me get rid of these curves. I've established what I like to kind of refer to as the driving surfaces for what this thing is going to be, and I've captured the basic volume of what I want to try and create. And at this point, all I need to do is start picking through, and with nothing other than the bridge tool and 2 segments in between, I can start putting this thing together. I can say there's a vent there. Maybe there's a bigger vent here. This is a super, super powerful workflow, and you don't need to get real uptight about how it goes together because, again, it's really easy to delete these little Post-it notes or move them around if you change your mind at a later date. And so you can see how you can start capturing volume to create some shapes here that would be difficult to do any other way. And notice too that, you know, I'm not super uptight about the fact that these things aren't lined up, because through the magic of the match tool, I can always go at any time and not only match the edge curves, but I can match internal curves. So if I needed a specific cross-section to run through here, I could match this isoparam to a specific curve and force that section of that model to be straight. So I'm not super uptight about what even that I'm lining up here. It's just I want to try and capture volumes where I want openings and holes to be and stuff like that. Now, I've got a scenario back here where this guy's kind of hanging out in space, and at this point, I think what I'm going to do is I'm going to weld this edge. I'm either going to weld this edge or I'm going to bridge this edge. So this face out here is kind of dangling out in space, and so I'm just going to get rid of it because I don't need it. And then I'll do a little bit of adjustment out here. Maybe I'll just pull this out so it lines up, and I'm not even going to sweat the fact that that's a little wonky right now because I can always straighten that out later. And then I'll just do my last bridge. Edges from here to here. And you'll notice that I start having, I start getting a helmet. Well, the last thing I need to do is start extruding my holes so that all my creases and nasty go away. And in this case, I'm going to extrude these guys together. And you run into a situation where you say, hey, it's not smooth. Well, it's not smooth because you're not done yet, and you need to get all of these guys because all the other openings, all these unresolved inside edges in the rest of the model are throwing creases. So I can even speed this up by doing this. Neat trick with the extrude tool, it'll only extrude exterior edges. So I can grab this, 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 this. Actually, I hit the L key. That selects everything. I'm going to just deselect these because I'm paranoid. They won't extrude, but it just helps keep me organized in my tiny, confusing, unorganized brain. And when I run the extrude command, and I'm going to extrude off this disk right here, you'll notice that it ignores everything that's not an external. It's got to think for a second here. There we go. And I'll go one more time. And again, this is a situation where I used to be like, oh, I ruined it. Well, it's not ruined. We just need to run one more additional command here, which is make uniform, or as I like to refer to it, the fix model command, which will go back and straighten out all our isoparams. And you can see, without belaboring this too much, how you can start with strips and bridging and some extruding to lay out exactly the kind of topology you want. And now we're right back to step one, which is our box modeling, pushing and pulling edges around. Take that, NURBS. And you end up with something to this effect. Symmetry on. Cool thing about this is now that you've got one helmet, as a product design consultant, I'm always trying to figure out how I can make more dollars per hour. And this is what we like to call the $500 an hour tool, because now I can do variation number one, save that out as a file, undo, 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 undo. Oops. Not undo that far. Variation number two. You guys feeling me here? Are you seeing the potential workflow / profitability improvements that are possible here? Okay. You guys all get this. Strip modeling. Start with some strips, bridge them together, extrude out where you need details, create seriously, seriously insane geometry in seriously, ridiculously short amount of time. I mean, you saw the layout on that model, on the helmet model that I was just working on. You know, I think that was like 9 minutes of layout, and we had something that you could start pushing and pulling and turning around into a model. The front and the back here, I did that with the match command, just like we did on the bicycle. You know, I had that really kind of stanky front end on that thing, and I just matched the internal isoparam. I also matched the external isoparam, and then just extruded this in a little bit to get that nice return. Same thing back here, just extruded these two out. You know, is this a variation you can build for? You know, 1, 2, 3. So that's kind of the last technique that I wanted to demo. Any thoughts, any questions? Anybody want to call me out on anything they think is complete and utter bunk? Do it now.
Kyle, thanks for sharing those. One question is you mentioned that you used the match command
Mm-hmm.
on this. Could you just show how you match an internal ISO curve?
Sure can.
I don't know if you've shown that yet.
What would be a good example on this? I tell you what. Let me, instead of trying to,
Yeah, you can just maybe show the different model.
let me do something a little simpler. Not that the command is not sufficiently awesome, but no one needs to watch me stumble around. So if I go to the top view and I take a NURBS curve, I'm going to do something fairly extreme here. Notice that not only is it not round, it doesn't have the same number of points, it doesn't have, you know, any type of relation to the topology or anything crazy like that. It's also going to force the cylinder in and out, all this kind of stuff. This is kind of the type of things that make tool designers worry. And in this case, I go to the right-hand view, I'm going to match this isoparam right here to this curve, and it will force
Yeah, you need to click up on the command line option. You need to click mid-surface.
there it is. There we go. And now you just want to tell it where it's going, and in this case, since it's a really complicated one, I'm going to modify my start point, and I'm going to say start here, and then I'm going to add some detail.
I think at least for me, Kyle, your screen's frozen. I don't know if you want to maybe stop sharing and then start sharing it again.
Did it freeze up? Is everybody else frozen?
Oh, okay, it was just me. All right, continue on.
All right. So we'll do that. I'm going to right-click to accept. You'll see that it forces that. Now, I didn't let it refine. If I let it refine, it will actually add additional detail. And this is a really brutal example. I'm just going to let it do its thing. But you can see how you can force. If you were to refine it and let it add geometry, I did not let it add geometry, so it didn't change the topology on the model, but you can see how it forces it in there. Mid-surface. There. Use refinement. Yes. You'll see that it's actually going through and variating, and it added some geometry in there, but you'll notice that the curve is matched exactly.
Go ahead and turn on the control points on the T-spline, Kyle. So it just added those locally there.
Yep. So we've got 1,000,000 points in this curve, and the T-Splines model stayed nice and simple. You love this. This is a great tool.
We've got a couple of questions about jewelry. To be honest, I think probably 3/4 of the people here today are jewelers.
Great.
And someone's wanting to see a signet style ring with a flat round top surface and some other stuff. Actually, it turns out that Juan and I think we just finished yesterday some new jewelry tutorials that we'll be throwing up online. So I'll send a link to those with the follow-up of the webinar so you can watch those.
There is actually a flat signet ring demo that we do in the training. So
that's what we're putting online, Kyle.
Oh, there you go.
Yeah.
You guys have seen it here. Matt is now putting me out of a job.
Just one more comment about training, though. We're doing in Vancouver in a couple of weeks. We're doing our first ever level 2 T-Splines training, and then also we're doing a user group meeting in the afternoon. So we have a pretty small venue, so it's really limited seating, but there's a couple of spots left. So if you'd like to get more of this, Kyle will be there, I'll be there, Sky will be there, a few others, Bob McNeil will be there in the afternoon. We'll send a link. You can sign up for that as well. But this is Vancouver, British Columbia. So.
Hey, one more thought, Matt. I was just scrolling through the questions here, and Rob, going back to your stone question, there actually is a really cool workflow. If you were to scan the stone that you were working on, if you go back and look at Kevin Pascoe did a converting scan data through ZBrush into T-Splines tutorial, and then I did one using 3D Coat. You can get a really cheap Next Engine desktop scanner for I think under a couple of $1,000s. You could scan your stone and then essentially convert it into an object that you could bring in here and model around, or even turn it into something that you could Boolean with. And that, if you've got a stone that's really critical as far as matching the shape of the stone into the piece that you're working on, and you don't want to guesstimate because you're working in gold, and gold is $25,000 an ounce now or some ridiculous thing like that. I would highly recommend scanning it, running through Kevin and my tutorials on converting stuff into T-Splines objects using ZBrush and 3D Coat, and then now you've got an exact replica of the piece that you're working on, and the precision to which you can work is really pretty awesome. So that would be one more thought onto that, as opposed to eyeballing a curve off a picture, would be to actually go ahead and scan the stone and go from there.
Okay. Well, I think that's about all the time that we have. Just before we sign off, though, Kyle, I don't know if you're in the position to pull up a web browser, but one thing we just barely are starting this week on our forum is doing a weekly modeling challenge, and this is something that the motivation behind this is we're looking for more interesting ways to do some of our testing here. So if you just go to the T-Splines forum and let's see, and then go to T-Splines for Rhino tutorials. Here's just a couple models that all of us, or a lot of us internally, are just going to take a stab at. To be honest, there's a reason why we have Kyle do these webinars. We're not very good at modeling, so I don't know that that we'll get super good models out of here. But if you'd like to play with this as well,
they make up for not modeling by how great the coffee at the office is, though.
That's funny. Go ahead and go to T-Splines for tutorials, Kyle. And then weekly modeling challenge. So we're going to be spending a couple hours this afternoon taking a stab at this. So if you want to try out some of the stuff that Kyle was showing today, if you scroll down, there's some of the images that we'll be taking a poke at. You can share what you've done, see how much better it is than what some of us will probably do, and hopefully it's a way to continue to learn. So, okay, all right.
Thank you, everybody, for coming. If you have any other questions, throw them out now. Otherwise, keep an eye on the webpage for announcements for future webinars, and I hope you enjoyed it. You can feel free to contact us through the forums or by email if you have any other additional questions. Thanks, everybody.
Okay, see ya.